Hello everyone, welcome to GRE question of the day. Today we will discuss a question on quadratic equations. As you can see, our today's question is a quantitative comparison question wherein we are given that x and y are both greater than or equal to 0 and we are given two quantities a and b such that quantity a is equal to root over x to the power 12 minus y, while b is equal to the product of x cube plus root y and x cube minus root y. Next, we are asked to determine if a is always greater than b, that is option 1, or if b is greater than a, that is option 2, or if a is equal to b, that is option 3, or if the relationship cannot be determined from the given information. Before we move on, I would request all of you to pause this video and try to solve this question on your own. In case you couldn't do it, do not lose hope, since I'm here to help you out. Before we move on to the detailed solution, let us take a quick glance at the correct answer. As you can see, the correct answer is option 3. That is, the two quantities are equal. Now let us see how we arrived at this particular answer. So, it is given to us that x and y are both greater than 0 and a is equal to root over x to the power 12 minus y. Now, x to the power 12 when taken a square root would yield x to the power 6 and hence a can be rewritten as x to the power 6 minus y. Now, b is equal to x cube plus root y into x cube minus root y. So this takes a form of a plus b into a minus b, and we know a plus b into a minus b equals a square minus b square. Thus here we can rewrite b as x cubed to the power 2, that is x to the power 6, minus root y whole square, that is y. And thus we see that b and a are equal in values for all values of x and y, thus giving us option 3 as the correct answer. I hope you guys could follow the solution. In case you couldn't, please pause this video and go through the typed solution here. With this, we come to an end of our today's session. We'll be back soon with more videos. Until then, keep working hard. Thank you and all the best.